Hello and welcome to a video about forces, and we're looking at terminal velocity, and this is for Unit 2 Physics for GCSE Science. Now, when we refer to terminal velocity, it's usually to do with falling objects. The objects could be either falling through a liquid, so we've got a marble here falling through a glass tube full of water. It could be water, it could be something like oil, which is sometimes an experiment that's done in class. And we could have something like a tennis ball falling through the air. It's a random example of a tennis ball falling from a tall building. But either way, we're talking about falling objects, and these objects are falling through a fluid. And by fluid, we mean either a liquid or a gas, and in this example, it's air. So it's to do with objects falling through liquid or air, and we say it's objects falling through fluids, which is actually specifically stated in the specification. But what we're looking at is the types of forces that act on these objects and what effect the forces have on the movement of an object that's falling. Now, the classic example that they give is the parachutist. Again, they do mention parachutist in the specification, so let's look at how it works for one of those. Now, to start off with, we have different stages of the journey, so I've numbered those 1 to 5. And in the very first stage, we've got the parachutist who has just jumped from the plane. We have two forces that are acting. The first one going downwards, that's due to gravity, and we call that force the weight. So because of gravity, the person is pulled towards the earth, and that's given their weight. Now, the other force acting in the opposite direction is the air resistance, which is acting in an upward direction. So we've got the weight pulling down and we have air resistance pushing up. And from the previous video, if you remember, the longer arrow represents a bigger force. So we've got a bigger force going downwards. That means the person is accelerating. The person is accelerating downwards because we've got a bigger force downwards. Now, after a while, you can imagine the person has started moving faster, so the forces change. The weight, in fact, stays the same, but it's the upward force, the air resistance, that changes. It becomes larger because the person is moving faster. So we've got a slightly larger arrow here showing a larger upwards force, but weight is still larger, so the person is still accelerating, but they're accelerating a little bit less. So they are getting faster, but not as much as they were previously. After a while, what happens is the air resistance becomes the same as the downward force of weight, and the person reaches a steady speed. And it's this steady speed of a person falling after the forces have become balanced that we refer to as terminal velocity. So this is what we mean by terminal velocity. It's when an object or a person is falling, and the air resistance and the weight become balanced. The person starts falling at a steady speed, and that's the terminal velocity. Now, an interesting thing happens when a parachute is open, so let's see what goes on then. When the parachute is open, we've still got the same weight going downwards because that doesn't change. The person doesn't lose weight as he or she is dropping, but what does happen is the upward force, because the parachute has been opened, the upward force increases greatly. The parachute opens, it doesn't suddenly start moving upwards. That doesn't happen at all. What happens is the bigger force going upwards would cause the parachutist to slow down, and because it's quite a large surface area up here, he slows down quite rapidly. And finally, after he has slowed down, what we get is the same downward force of the weight, but again, the forces become balanced. He's going much slower, so this is supposed to be the same size arrows going downwards, and again he reaches a new steady speed. It's going at a steady speed or steady velocity, but it's slower. In actual fact, it's a new terminal velocity. It's a slower terminal velocity. So what you should be able to do is to describe the forces on a falling parachutist in terms of the weight and in terms of the air resistance, and say what is happening to the parachutist based on the size of those forces at different points in the journey. You are also required to look at or interpret a graph of a falling parachutist. So let's do that now. Here we have a velocity time graph for a parachutist. It's a very strange shape, but if you think about it carefully, it does make sense. Initially, when we start the jump, we have a velocity of 0, so that's the person, or a downward velocity of 0 should we say. The person is standing on the plane waiting to jump, and as soon as they jump, their velocity starts to increase. And it increases rather rapidly, so we say the parachute is accelerating rather rapidly towards the earth. The rate of acceleration decreases until eventually, at this point here, the parachutist is going at a steady speed. That's our terminal velocity. You can probably guess that at this point here is when the parachute opens, so the velocity decreases very rapidly, so the person slows down and then eventually reaches a new terminal velocity, a new steady speed, which is much slower, and then eventually touches the ground. And what you should be able to do is relate this graph to the different diagrams that we showed in the previous one. So if we look at the first one, that's the one where the downward force is much bigger than the upward force. So the person is accelerating quickly towards the earth. The second one, the upward force has increased because air resistance has increased, but over here for the flat part, the upward force of air resistance and the weight are equal, they're balanced, so the person goes at steady speed. The resultant force is 0, the person falls at a steady speed, and over here is when the parachute opens, and you can see a much larger upward force due to the air resistance of the parachute, and the parachutist then slows down. And in the last one, we've got equal up force and equal down force, and therefore the parachutist is now going at a steady velocity for a while, enjoying the journey for the last part, and then eventually hits the ground. So again, it's just adding what we did on the previous slide, so what's happening at different parts of the journey over here, to a graph of the journey, and you should be able to explain what's going on at the different parts.